The next concept in this subtopic of relative velocity is the shortest distance of approach. Now we have learnt one thing here in relative velocity. If you recollect, this is in position R1 and this is in position R2. If the two particles should meet, this is the way they move. This will be V1t and V2t. Did we deal this?
Yes, sir.
Right. Now in this concept we explained that if the two particles should meet, relative velocity of 1 with respect to 2 and relative velocity of 2 with respect to 1 should be along a straight line joining their initial positions. If the two objects should meet, relative velocity of 1 with respect to 2 and relative velocity of 2 with respect to 1 should be a straight line joining their initial positions.
Yes, sir.
Right? We have done this, yes or no?
Yes, sir.
Excellent. Now what if the relative velocity is not along the straight line joining their initial positions? Now this was the state when the two particles are meeting. This was the state when the two particles are meeting. If the two particles are not meeting, then under those circumstances from R1 to R2, this will go this way and this will go this way. By the time this particle came here, this particle will be somewhere here, see? So by the time the particle crossed away till here, the particle is here. Now the particle keeps going ahead and this will go this way. The two particles will not meet. Now when the two particles do not meet, relative velocity of one with respect to the other will not be along a straight line joining their initial positions. It will be along a line joining either this way or this way. Because the concept of relative velocity is keeping one particle at rest and describing the motion of the other particle. Now if these two particles are going towards this particular position, you are coming here, I am coming here, you are coming here, I am coming here, both of us meet at one point. So if you ask an ant or a fly on my shirt, it will not recognize the fact that I am moving. It will only recognize the fact that distance between you and me is decreasing. If distance between you and me is decreasing, it will feel that you are moving straight towards me. But in any case, if we both don't meet, then it will feel that you moved straight away this way if you have crossed me. On the contrary, if I am crossing you, the ant will feel that you are going straight in this direction behind me. So now we are interested in finding out the shortest distance of approach when the two particles are not meeting. Shortest distance of approach. Shortest distance of approach. Consider a standard example. There is a particle A, there is a particle A here and particle B here. The initial separation between them is 10 meters. And both start moving simultaneously. The initial separation between them is 10 meters. Both start moving simultaneously. One is moving towards the right, the other is moving towards the positive y-axis. The particle B is moving towards the positive x-axis, particle A is moving towards the positive y-axis. Now 100% we know that the two particles will not meet, as this is moving straight and this is moving up. But I can assume a shortest distance of approach for this. There would be some state where I tell you that B is here and A is here. This will be the shortest distance of approach. This will be the shortest distance of approach. Now this distance is velocity into t, say. Both started moving with the velocity of 10 meters and 10 meters per second. Let me say assume that velocity of B is also 10 meters per second and velocity of A is also 10 meters per second. Now velocity of B means it is this distance, velocity of A is this distance. So at some instant this distance will be the shortest distance of approach between them. So I can tell you this distance will be 10 minus Vt.
Yes, sir.
And this distance will be V into T. The hypotenuse S will become root over of Vt whole square plus 10 minus Vt whole square. See if you are convinced. This distance is Vt. Both are having the same speed of 10 and 10. So I am calling it V. So by the time the particle A came till here, the particle B reached here. So this distance left over will be 10 minus Vt. This distance will be Vt. Pythagoras theorem. My requirement is ds by dt should be equal to 0. Implies, first of all, I'll square this. V square t square plus 10 minus Vt whole square. Now differentiation of this should be equal to, have a look at this. I am using chain rule here. Differentiation of s square with respect to s into differentiation of s with respect to t. Because directly I don't know the differentiation of s square with respect to t. Now this will be equal to, right hand side it will be v square into 2t plus differentiation of this with respect to t. Again I will use chain rule. Differentiation of 10 minus Vt whole square with respect to 10 minus Vt into differentiation of 10 minus Vt with respect to t. Now this will be 0.
Yes.
ds by dt will be 0. Right? Why? That is the condition for maxima.
Yes.
When I equate this to 0, minima, here distance should be minimum. This will be 2v square t plus 2 into 10 minus Vt into minus v.
Yes.
Substitute the value of 10. Will I get the time after which the two particles will be at a minimum distance?
Yes, sir. Yes, sir.
Now this is one way of solving the problem. Traditionally, the most orthodox way of solving. First of all, once I get that time, now 0 equal to 2 times v square is 100 into t plus 2 into 10 minus 10 into t into minus 10. So bring this towards the left hand side, 2 gets cancelled out. Okay, this will be 10 gets cancelled out. 10t is equal to 10 into 1 minus t. This also gets cancelled out. 2t is equal to 1t is equal to half a second. So after half a second, both the particles will be at the closest distance of approach. What will be that closest distance? Substitute this half a second in this s. And s minimum will be equal to root over of 10 into 1 by 2 plus 10 minus p is equal to, what is the value of v? 10. 10 into 1 by 2, 10 minus 10 into 1 by 2 Vt. This will be 10 by 2. Right? You have a square here also. Done with that? Here also, yes, 5 root 2 meters would be that minimum displacement, and this will be the time after which they both will be at the closest distance of approach.
Yes.
But then whole of this can be looked at with a different approach. Now you are looking at whole of the problem with respect to ground. B and A, both of them are with respect to ground. What if I look at the problem either with respect to B or with respect to A? Let's see that approach. You are supposed to get the same answer. We will verify that. Take this down. Try to concentrate on this. You are trying to solve the problem with respect to B. That means, first of all, in the concept of relative velocity, B will be at rest. A will be moving along the direction of relative velocity. A will be moving along the direction of relative velocity. That means velocity of A with respect to B. Who is the observer? The person in the second place is the observer. This will be VA minus VB. VA minus VB. Now I know VA is in this particular direction. VB is in this direction. Minus VB in the sense now VB should be in this direction. Minus VB. Now
Yes,
VA and minus VB, when I take the resultant, it comes in this particular direction. This is 10, this is 10, this will be 10 root 2 meters per second. So this magnitude of VAB will be 10 root 2 meters per second. In which direction? Obviously making an angle of 45. Why should it make an angle of 45 here? This is 10 and this is 10. Now that means if there is a digital camera fit on this particular particle B, for the particle B it will appear that particle A is going along this direction with what speed? With a speed of 10 root 2 meters per second. This is the concept of relative velocity. This is describing the motion of A with respect to B. implies it will be velocity of A with respect to B, implies VA minus VB. The particle B will be at rest. Assuming that A will phase motion will be described as 10 root 2 meters per second along this direction.
Yes, sir.
Right? Now, you are asking me for the closest distance of approach. Don't you think this will be the closest distance of approach, a perpendicular drop here?
Yes, sir.
Now, this distance you are telling me is 10 meters. This is 45. What will that be? Shortest distance, yes, minimum is 10 sine 45. 10 sine 45. 10 into 1 by root 2.
5.
Is this the answer that we are expecting?
Yes, sir.
The answer that we are expecting is 5 root 2 meters. 1 second. We need to know even the time. What will be that time? Time taken for these both particles to come to the shortest distance of approach will be the time taken by the particle A to travel this distance.
Yes, sir.
With what velocity is the particle A traveling this distance? 10 root 2 meters per second. So by the time the particle A comes till here, that will be the time taken for the shortest distance of approach. Now what will be that time? Displacement by velocity. Displacement is 10 cos 45. 10 cos 45 will be the displacement. Velocity in that direction will be 10 root 2. See if you are getting your required answer of half second or not.
Yes, sir. Yes, sir.
Is the concept of relative velocity here clear?
Yes, sir.
Now we take this problem one more step ahead. You are speaking about an equilateral triangle. 3 particles are on the vertices of an equilateral triangle. 3 particles are on the vertices of an equilateral triangle. All 3 particles start moving simultaneously with a velocity of u. All 3 particles start moving simultaneously with a velocity of u. Write down this problem. The 3 particles on the vertices of an equilateral triangle start moving simultaneously with a velocity of u, always aimed towards the next particle. Now, all 3 particles start moving simultaneously with a velocity of u, always aimed at the next particle. Please mind the last statement. Always aimed at the next particle. In the sense, at this instant,
So always aim to the next particle or next vertex.
next particle, that's the point in it. So this is aimed with a velocity of u, this with a velocity of u, this with a velocity of u. But then the moment this particle moved here, this will have to take a turn. This will slightly take a turn. Because this took a turn, this will take a turn. Now this should take a turn. So finally they will all meet at the centroid. Because at every instant, the moment this particle took a turn, this particle will take a turn. This should be aimed at the next particle. Immediately this will take a turn to be aimed at the next particle. They move about and then they will be landing up at the centroid of the equilateral triangle. Now how do you know that they will meet at the centroid? By symmetry I can make a guess that they will meet at the centroid.
Yes, sir.
And always one particle is aimed at the other particle. Suppose this one particle is here, it will be aimed at this. This will be aimed at this. This will be aimed at this. This will be an equilateral triangle. So in actual practice, the equilateral triangle may be turning, but the area of the equilateral triangle will be decreasing and it will merge into this particular point at one stage.
Yes, sir.
So how do you deal with this particular problem? The time after which they meet, displacement by velocity. This is relative displacement by this is relative velocity. This is relative displacement by this is relative velocity. Right? Now if you are taking normal displacement and normal velocity, this is relative. Now when I am taking displacement and velocity, both should be absolute. If I am taking relative displacement, I will have to take relative velocity. Now what will be the relative displacement? Initial separation minus final separation. Try to visualize this. We said in the concept of relative velocity, you are trying to keep one particle at rest. Now suppose I am describing the motion of this particle with respect to this. Then that means this particle will consider itself to be at rest. There is only one way that this particle can meet this. It will have to travel a distance of d or a, the side of this particular triangle.
Yes, sir.
In the concept of relative velocity, if you are telling me that the relative velocity of this with respect to this is taken, what will be the relative displacement? Relative displacement will be a. When this particle considers itself to be at rest, there's only one way this particle meets it. Come straight towards this. Come straight towards this. Is that making sense? Now, relative displacement will be a. Relative displacement will be a. Relative velocity will be, this is theta, that is 60 degrees. This will be u cos 60. U minus u cos 60. Obviously with a negative sign because both of them are approaching each other. Right? A divided by u minus u cos 60. This will become a divided by u plus u cos 60. So this will be a divided by u plus u by 2. A divided by 3u by 2. I'll get 2a by 3u is the time after which this particle will be meeting this particular particle. Where they meet with respect to ground, we know they will be meeting at this particular point. So this is the time after which all three particles will be meeting at the centroid. Look at the alternative way of solving this. Now we know that they will be meeting at the centroid. Now the centroid will be in the ratio 2:1. Centroid will be in the ratio 2:1. If the centroid is in the ratio 2:1, first of all, this is a by 2. This hypotenuse will be this particular height, root over of a square minus a square by 4. This will be a root 3 by 2.
Yes, sir.
Now this particular distance will be in the ratio 2:1. So it will be 2/3 of this quantity. 2/3 of a root 3 by 2. This will be a by root 3. Now you are telling me by symmetry you are able to make a guess that all three particles will meet at the centroid. So now I will try to calculate how much time will this particle take to come till here. Now I actually don't know the distance it traveled. It could come somewhere in this track. But I know the displacement that it has covered. The displacement is a by root 3. So the time after which it comes to this point, removing the distance, let me take the displacement by velocity in that direction. Displacement is a by root 3. Velocity, this is u and this is 30. It will be u cos 30. The u I resolved along this direction. That will be u cos 30. U into cos 30 is 3 by 2. 2a by 3u. This is the answer that we are expecting.
Yes, sir.
Now we can actually generalize this. Today you are speaking about a triangle and the vertices with 3. What if there are n sides of a regular polygon? I am not drawing the upper part of it. All particles start moving simultaneously. All particles start moving simultaneously. Now this is u and this is u. If this is a regular polygon of n sides, what can you claim this particular angle be? This angle 2 pi by n. I'll do one thing. I need some space to deal with that. Take it down till here and deal with that. Now if we generalize this, instead of a triangle I can have a square. Instead of a square I can have a pentagon, hexagon, so on and so forth. Now let me consider a regular polygon of n sides. Right? It will be a regular polygon of n sides. All the vertices have particles. Now this particle started moving simultaneously. This particle started moving with a velocity of a. This displacement is a. If it has a polygon of n sides, this angle will be 2 pi by n. Why? Because this angle will be 2 pi by n. N sides, that will be 2 pi by n. So this angle will be 2 pi by n. Now that I know this angle, relative displacement by relative velocity, relative displacement will be a. Relative velocity will be u minus